Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. We meet again in shear strength. So this is a tutorial video for the shear strength, and we are now discussing the triaxle test. And we know that triaxle tests have three different tests: UU, CD, and also CU. So this one is for CU tutorial. Okay. So we know that for the CU, oops. Okay, wait. Okay, for the CU, we know that during the first stage of the consolidation, we will open the drainage. So we allow the dissipation of water from the soil sample, and we wait for the consolidation process. Okay. But when we continue the test, we adding more load. But during the stage of shearing, we now close the drainage valve, so we will see some different activity in the soils. Okay, until we reach the failure, until the soil sample reach the failure. Okay, let's skip this one. So let's go straight to the example. Okay, right. CU test. Alright. So okay, this is a practical application for the CU, right? Now, okay. Now let's say we have a example that we are given the cell pressure. Cell pressure stress 3, okay? Cell pressure is stress 3. Minor principal stress, cell pressure. So here is the questions. Okay, here at the top is the questions. So this is part of the solution. I already prepared the solution. Okay, but let us visit first the questions. So we are given stress 3, cell pressure. We also given deviator stress or additional stress that applied during the consolidation and also shearing. Then we also already given the major principal stress. This is E, stress. Or stress 1. Stress 1. So major principal stress is stress 1. And for the CU, as we have a drainage, of course we can measure the pore water pressure. Okay, pore water pressure. So we need to obtain shear strength parameter for two different states. Let's say the first one we want to obtain in the total stress, another one we want to obtain in the effective stress. So I think for the total stress, it doesn't have any problems because total stress we will use the stress 3 and also stress 1 directly. But if you want to get the shear strength in the effective stress, so we need to calculate. We need to calculate to consider the pore water pressure. We need to calculate to consider the pore water pressure. So for the major effective principal stress or stress prime, okay, stress 1 prime, and for the minor one, stress 3 prime. So the equation is simple. So if you still remember, stress effective is total stress minus the pore water pressure. And I hope you also remember from the water in soil, pore water pressure is unit weight of water times the height that have the water. So total stress is gamma unit weight times the height of the soil layer. So okay, so here if we already knew this is equation for the effective stress. So stress 1 major is stress 1 major prime stress 1 minus the U, okay, the pore water pressure. Similarly for stress 3 prime, it is stress 3 minus the U. So I already calculate and I got this value. So next what we need to do is to plot the graph. Okay. So here I already start to have a graph. So let's say this is my graph paper, just a normal one, no need for the logarithmic graph, just a normal one. So first, draw the axis for x and y axis. So for the x-axis, so we plotted the graph. It is a normal stress graph, kilonewton per meter square. So I choose to have a 100 for every 10 cubicle. So 100, 200, 300, and 4 and until 1200. Okay, how I got this scale, because I checking first the maximum measure principal stress that we need to plot. So the biggest value is around 1200 kilonewton per meter squared. So that's why the scale up to this value. Similarly for the for the y axis, so I use the similar scale. So if it is 200 here, so I use 200 here for a simple one, for the simple approach. Okay. So as we know, we already have in the yellow bracket, in the yellow table. So this is for the total condition, total stress condition. So let's start with the first circle. First circle is stress 3 equal to 200 and stress 1 equal to 317. So we plot like that. And next, proceed to the second one, 400 and 642. And the third one is 800 and 1268. So we get the three different more circle for the total condition. To obtain the shear strength, so what we have to do is we have to draw the failure line. So draw the failure line, failure envelope, so we can get the C value and also the phi value. Alright, now continue to get the effective stress. Okay, we already calculate just now the effective stress for the measure stress 1 and also for the stress 3. So start with the first more circle and second, and continue with the third one. Similarly, we can get the failure line by combining all the lines tangent to the more circle. Okay, tangent to the more circle. Get the best fitted line. And we can obtain the phi and also the C. Okay, note that when we have a effective stress condition, the C prime and phi prime, this is phi prime, okay, phi prime is much more bigger compared to the total condition. The C prime and phi prime is much more bigger in the effective stress condition compared to the total stress condition. So it seems like it's much more better high strength when we check for the effective stress of the soil compared to when we do the analysis using total stress condition. Repeat again. So it looks like we have a better strength with a higher C and also higher phi value when we calculate the condition in the effective stress compared to the total stress condition. So that is one example from the data that given from the soil sample that we take from a site. Okay, I think that's all for now. So assalamualaikum and thank you.